Here it is today. We're recording this on Friday, but we're releasing this on your pub date Tuesday. Rad
Great.
Future, the untold story of nuclear electricity and how it will save the world. Isabelle, nice to see you.
Nice to
By
see
the
you
way,
as
we
well.
did
That
a
was
whole
a
issue
great
of
intro.
Skeptic on energy, in which we published Robert Zubrin's article on the case for nuclear.
Oh, great. When did that come out?
Let's see, that was fall, summer of 23. So
Wow.
well, we
Okay.
support
Not that
the
long
we
ago.
support the cause. Yeah, no, it's astonishing to me that just everything you wrote in this book, which is so clear and so obvious and such a fun read. By the way, you're a good writer.
Thank you.
How is it possible this is not already happening on a huge scale?
It's a good question. As you mentioned, the book, I go through the entire history of nuclear, just the technology itself. I think people don't understand the emotional impact of the fact that nuclear fission was discovered in 1938 in Germany. Um, I like to give the case of AI. Right now, we're living in this age of the birth of AI, so we still have all the possibilities in your mind, right? It could be great, but it could be scary. But we don't have a visual of the absolute worst use of AI yet. And with nuclear, the first introduction of the word to people everywhere was bombs. And so, you have images in your mind of mushroom clouds and children crying, running away from buildings. So that was arguably the worst, introduction of any technology ever. And then for the 15 years after the discovery of nuclear fission, only the military really can build and operate nuclear reactors. So nuclear is very tied with the military, with big government, and obviously with the bomb. So that's a part of the reason why. Um, but I'm very, very, very excited because I have to say, I started doing this work 5 years ago, and I had no idea we would be here today where we are having the conversation again on nuclear, and people are way more open-minded to it.
Yeah, let me read something from your book here. Again, you're such a fun writer. I learned a lot of things. I didn't know what TLDR meant. Too lazy, didn't read. So it's a nice little summary of the chapter there.
Too long, didn't
Oh,
read,
too
but
long to
yeah.
read. That's it. Yeah. I didn't read those. I actually read the chapters. So
Oh, nice.
so here's what you write about your journey here. In 2019, at the peak of my climate anxiety, I decided to do a 10-day fast in a clinic in Spain. Well, that sounds like fun. Better health was the main motivation. Little did I know that fasting is a spiritual practice that's been used historically for deep insights. After 3 days of pure misery, that's a shocker, staring at my phone and saving recipes for when I could finally eat, clarity set in. I felt more energized and inspired than ever. My eyes were bright and shimmering with excitement. After the fast, I headed to the secluded cabin to do some more soul searching and try to understand what role I could play in tackling climate change. One night, while brushing my teeth and staring at the mirror, as one does,
As one does.
a random thought popped into my head. What if I became a nuclear energy influencer? To be clear, I knew it was an insane idea. Nevertheless, I decided to run it by strangers next to me in lines or on airplanes, and the reaction showed me that this wild idea could have a big impact. So maybe give us a little bit of background. How do you go from being a fashion model to a nuclear energy influencer?
As one does, I guess.
Yeah.
Yes, as you mentioned, back in 2019, I was still working as a fashion model. I was also building a cosmetics brand, which, at the time I thought I wanted to be an entrepreneur, um, which is also, as you know, a very, very hard career. And, I remember waking up one day in 2019 and seeing the images of the Amazon on fire. And that was a especially brutal year for wildfires. As you mentioned in the introduction, you remember the Australian bushfires. So we had the Australian, the Amazon, and then the California fires, where a lot of the images of the orange skies also, were circulating on social media. And I just remember feeling very hopeless about the future. I grew up with climate change, like a lot of people in my generation, but it always seemed like a problem that we were going to have to deal with eventually. And that moment in 2019, it just felt very urgent, very present. And I just couldn't continue modeling or just building a cosmetics brand without doing anything about the climate crisis. in hindsight, it sounds so naive, that I even thought about this. Oh, I'm going to do something to save, the world from climate change. But it was really just from a place of despair. And as you read in the book, I went to a fasting clinic in Spain, which does not sound fun. I fully understand that. But I was very into intermittent fasting at the time, so I wanted to do it, as I mentioned, for health reasons. I guess I'm one of the least woo people you're gonna meet in your life. So I didn't go to a fasting clinic from a spiritual woo-woo mindset. It was purely health reasons. But yes, turns out that at the end of it, I had this random idea. What if I become a nuclear energy influencer? And I knew it was a crazy idea because at the moment I thought it, I laughed. But I kept pitching it to people. So I would be in an airplane and somebody next to me would ask, "What do you do?" I would say, "I'm a nuclear energy influencer." And they would be so blown away. The responses were never like, "Oh, okay." Never like a bored thing. And so that told me that there was potential, at least for an interesting conversation.
Yeah. So to people not in social media like you are, how do you do that? How do you make money? I watched a couple dozen of your TikTok videos. They're really great. By the way, it's not a huge time commitment because they're only like 30 seconds to a minute long
A
each,
minute,
but they're
yes.
very effective.
Mhm.
How do you monetize that? How do you support yourself like and do this professionally?
So for a long, long time, I was a fashion model, which was a very financially rewarding career. So I did have a lot of money from that. Then I had a little cosmetics business. Nowadays, I make my money from speaking engagements and writing books. But in the beginning, when you're making content on social media, it's a lot of work, and you're not monetizing it. And I don't think that necessarily monetizing straight from social media um, is very viable now. But when you have an audience and you have something that you can speak with authority on, you can monetize with speaking engagements and so on.
I see. Nice. Yeah. The other connection to me in this show and what I do at Skeptic is you're mentioning and referencing Richard Dawkins, David Deutsch, Carolyn Porco. These are all good friends of mine, and how they influenced your thinking in this kind of transitional period. So speak to that, especially Carolyn's tweet. This all got triggered by a tweet. It's crazy.
It's so crazy, and I have to say, I actually just came back from visiting Carolyn, and we
Oh,
shared a
nice.
beautiful moment of connection, of sharing how absurd this is that 10 years ago, she randomly tweeted something about molten salt thorium reactors, and I happened to see that tweet, and for some reason, that just stuck in my mind. I was very curious about the technology, how it worked, what it meant, why she was speaking positively about it. But let's start with Richard Dawkins because that was my introduction really to science. I grew up in a very small town in a rural part of Brazil. Some people ride horses there. That's how rural it is. And I went to Catholic school almost my whole life until I was 12 years old. So suffice to say, I never really learned about evolution. And when it was presented to me much, much later on, it was kind of presented like, oh, it could be evolution, but it could be creationism. So it was never presented as this is what happened. Um, so when I was 19 years old, I randomly read a book by Richard Dawkins called The Greatest Show on Earth, which was about evolution. And I remember to this day, I have this memory seared in my mind. I sat in bed. I thought the cover was beautiful, and that's why I picked it up. I start reading, and I get goosebumps, and my mind is just completely blown because I had never heard about any of that. And so, which is crazy, right? I mean, we're not talking about the 1800s. We're talking about something that happened a decade or so ago. So I went on Amazon, searched for the book, and then started buying a lot of related books. My next one was actually Our Inner Ape,
Mm.
which is a very interesting book. It got me into evolutionary psychology, which I was very interested in for a long time. But I just started reading a lot of popular science books, and that's how I ended up getting on Twitter because I had all of these questions and topics that I wanted to discuss, and nobody in the fashion industry shared those interests with me. So I resorted to Twitter and I started following you. I started following Dr. Carolyn Porco, Richard Dawkins, a lot of Neil deGrasse Tyson, a lot of scientists. And so, yeah, that's how I came across Carolyn's tweet, which is crazy to think. And I've always given her credit. And she also joined me. We can talk about the Diablo Canyon campaign, but she ended up joining me in my grassroots effort. So
Yeah.
it's an amazing story.
Yeah, you're featured in my book, "Giving the Devil His Due."
I know.
I think I sent you a copy of this because that must be how I came across your tweet because you were following me, so I followed back. So there it is on the bottom of the page. This is your tweet from I don't know when this was. Oh, February 10th, 2016.
A long time ago.
This was in the kind of the phase of the culture wars over the male gaze and what women should do when they get heckled by men. And you
Right.
wrote, "Here's what I do when catcalled: roll my eyes. If he's Hispanic, say chinga tu madre, put the earphones on, and continue with life." And I like that because it's like, yeah, what are you gonna do? Dwell
It's
on it?
Yeah, totally. It's the Brazilian in me,
Yeah,
Latin people are very pragmatic and very straightforward, and we grow up with a lot of that, so you just have to be really tough. And I remember there was a lot of the conversation, to your point about the male gaze and how horrifying it was and whatnot. I feel like the worst days of that element of the culture wars, at least, are done.
good.
But we're so thankfully we don't have to deal with that. But,
Yeah.
that's a part of my personality is just low agreeableness.
Mm. Oh,
I did that in the streets, and now I use it to talk about nuclear and do things that are a little bit controversial.
nice. Yeah. So, David Deutsch's book, "The Beginning of Infinity," which you discuss in your book, is very important because basically he's arguing with the right amount of knowledge, the right kind of knowledge, and as long as it doesn't break any laws of nature, we can do anything.
Right.
And that's really the premise of your book: is we have a problem that we need to solve. So let's look at the bigger picture there. Climate change, anthropogenic global warming is real, largely human caused. Not clear how catastrophic or existential a threat it is, but it's certainly something we need to do something about. So then the question is, well, what do we do? Right? So, and what is it we need? We need electricity. We need energy. Civilization needs energy. So let's go over the sources here. By the way, I wanted to mention the little graphs you have in here, the hand drawn, are so clever. Because they convey the information you need, but not in a boring graph. So that's kind of nice.
Yes, my whole goal with the book was to make it as accessible as possible, and I want the average person that's flipping through it in the bookstore to look at the graphs and think, "Oh, this is not a textbook. This is
Right.
not intimidating.
Well,
I can learn
the
about
cover
this."
is wild too, by the way. It almost kind of conveys I don't know, radiation or excitement or energy or something.
Energy, definitely like a ball of
Energy.
energy.
Okay, so we need electricity. Where are we going to get it? We need energy. Okay, so in this graph you have uh, currently global energy consumption. This is as of the end of 2023. Fossil fuels, 76%, of which oil is 30%. Coal, 25%. I'll round up or down. Methane gas, 22%. Biomass, 6%. Hydropower, this is hydroelectric power, right? Dams
Mhm.
have 6%. Wind, 3%. Solar, 2.3%. Nuclear, 3.7%. Okay, so your thesis of this is we need to increase the size of that slice of the pie.
Hmm. So that's where the numbers on energy and electricity get a little bit complicated because total energy consumption means energy in general. Um, while nuclear, solar, wind, and hydro, they can only make electricity. So the whole idea behind decarbonization or getting rid of fossil fuels is that the first step is to electrify pretty much everything we have. That's why there's a huge push for electric cars, electric heaters, um, basically anything that uses energy, if we can convert it into using electricity. And then the second step, and by the way, they can happen simultaneously, right? It doesn't have to be in that order. But the second step is to then make sure that all of that electricity is being created with sources of energy that are clean. And that's where nuclear comes in. But also, of course, we have solar, we have wind, we have hydro, we have geothermal, we have more obscure like tidal. I don't consider biomass clean, even though people call it clean. But biomass can include things like burning chopped up trees, which I think is tragic, that we would consider a clean energy source. And so I don't count biomass as that, or even burning trash in some cases. which, the particulate matter is still going into the air and there is still carbon emissions that are associated with it. But yeah, the goal is to really just electrify everything and then get all of our electricity from clean energy sources.
So, what's the difference between a clean energy source and renewables?
It's people have used it as this to mean the same thing, but in reality they're quite different. So renewable is usually something that can be replenished, right? You think of the sun, it's as replenished, it's a replenishable energy source. Same with the wind, same with water, geothermal. Now nuclear, because it uses fuel like uranium, is not considered a renewable energy source. But I would argue that's not a great argument because at the end of the day, we cannot just grab the energy of the sun with our hands and use it. We have to build solar panels. We have to build wind turbines and electric power dams. And all of those things require materials, which are finite as well. And so this idea that there is a truly renewable energy source is just false. And I think it has been used historically and politically to exclude nuclear from the clean energy conversation.
Hmm. Well, I have a Tesla and I have a supercharger station right across the street here. Are you telling me I'm not getting the electricity into my car from the electricity ferry? You mean it has to be generated from coal plants or something?
I know. Go figure it out, right? But, and that's one of the things that kind of bothers me when people who grew up in developed countries think it's so easy for us to just use less energy.
Hmm.
And a lot of it comes from the fact that they truly don't even grasp the privilege that it is to grow up in an energy-rich society. To your point, most people get home, turn on the lights, charge their phones, turn on the TV, turn on the laundry machine without ever thinking where all of that is coming from. It just seems like it's magic. It appears out of nowhere. But no, we have to create electricity. There is electricity in nature, in lightning and all of that, but it's not like we get enough of it consistently. So we have to create it. And yeah, there are several ways to create electricity. Um, a lot of it is spinning a turbine. So coal power plants, you heat water by burning coal, and that water creates steam, which spins a turbine and creates electricity. Same with methane gas plants. You light up methane gas, and it heats water, creates steam, spins a turbine, and so on. Nuclear is actually the same thing as that, except we're not burning fossil fuels. We are tapping into the energy that's trapped inside of atoms, which to me alone
It's
is
astonishing.
very cool.
It is very cool. Yes. Yeah. I was just looking at another one of your graphs, global electricity at the end of 2023. Yeah. You see methane gas, 22.5%, coal, 35.5%, hydroelectric power, 14%, nuclear, only 9%. Yeah, I think that's about the same ratio in the state of California here. Thanks to you and others, keeping Diablo open, but that's only 9% of California's energy consumption.
It's only 9%, but it is astonishing when you go and you visit and you see this relatively small power plant
Hmm.
providing, 9% of the state's electricity. And when you say 9%, it sounds very little, but it makes enough electricity for 4 million people.
Wow.
It's astonishing to go into the turbine hall where you have these two big but not gigantic turbines, and you imagine one of them is making electricity for 2 million Californians. Nothing compares to nuclear because of this power density. There's no other energy source that can make this much electricity in such a small footprint and with such small materials quantities.
Yeah.
That's why, nuclear is such a progression of energy. Because when I think of energy or of technology progress, right, what does it mean to truly have progress in technology? Well, the way I see it is you're creating a technology that can provide something that a previous technology did, in this case, abundant, reliable electricity, while reducing the impact on humans and reducing the impact on the environment. And that's literally what nuclear does. You don't have deaths from particulate matter, or it doesn't cause climate change, but it also reduces greatly the impact on the environment because you need to mine so little because it's such an abundant energy source.
Yeah, nice. Yeah, Diablo. I've never been there. It sure looks beautiful in the pictures. I've ridden my bike right up to the gate when I stay at Pismo when I ride my bike up there, and I just begged them, can I just please ride on this beautiful coast? Oh no.
You should. We should organize a tour there. I'll
Okay,
take you there.
thank you. That
You
would
would
be great.
love it.
But do
Yes.
they have to be on the coast or a body of water for the cooling process?
It's easier, obviously, right? Because you need water for cooling the reactors. They get very hot, but you don't have to. And the one example I love to talk about is Palo Verde in Arizona, which is it was the biggest nuclear power plant in the United States until a couple of years ago. And they are in the middle of the desert. And the way they cool the reactors down is they bring in treated wastewater
Hmm.
from the city. And that's how they cool the reactor down, which I think is the next step, right? Again, if we're talking about technological progress, to me, that would be the next step, that we can cool these power plants with treated wastewater.
So using California as an example, if we had 10 Diablo power plants, would that take care of 100% of our electricity needs?
For now, yes. I mean, then we have to think about electric vehicles in the future
Hmm.
and the overall increase in electricity consumption. We don't know exactly what the numbers are, but the estimates are that if we convert all of our cars to electric, all of our heating and all of that, we would triple our electricity needs
Astonishing.
by 2050, I
Yeah.
believe. So we would need more Diablo Canyons.
Yeah, you have those charts on the amount of land required. Oh, yeah, here it is. Nuclear, there, that little tiny dot in the upper left,
I know.
versus, solar panels. Like to get the equivalent of a Diablo nuclear power plant in solar panels, what's the number? It's huge. I mean, it's a massive difference, right?
It's something like 900
Um,
times.
yeah, like 900 times, I think it was. This is your data from our world in data, I think it is. Yeah, let's see. Yeah, it was like 900,000 acres or something of solar panels to make the equivalent of electricity from one nuclear power plant. And these things are, yeah, there's a bunch of them out by Palm Springs. On your way,
Solar farms?
solar farms. Yeah,
Mm.
hundreds and hundreds of them. I go out there every year, and most of them are not turning. You go
Mm.
by, you drive there. It's right off the Interstate
Oh,
10.
the wind farms.
The wind farms, yeah, yeah. Sorry,
Yes,
not solar panel. Yeah, the wind farms. Yeah, they're massive. I mean, these things are
I
just
know.
huge, and each blade is like 600 feet long or something. And they break down, I guess. And what do you do with them after they're not functional?
Right.
So,
Well,
yeah.
every technology has upsides and downsides. I do think that wind wind turbines are an upgrade over fossil fuels, right? When we're talking about, again, the air pollution standpoint. Forget about climate for a second. Just the particulate matter air pollution alone. Wind turbines are an upgrade. But yes, they have, huge downsides. They're not as reliable as nuclear. Wind's capacity factor is like 30%, I believe, 35%. And that means that, let's say a wind farm would be making its maximum amount of power only 34% of the year.
Mm.
Versus a nuclear plant would be making its maximum amount of power over 94% of the year. So it's almost on at all times. Um, and I think one of the reasons why people don't like wind turbines very much is for the issue you pointed out, which is you drive by them or you walk by them and you see them just standing there. And it feels like such a huge waste of space. And, they kind of ruin the landscape. But I'm not opposed to wind. I think the thing that bothered me the most about the last few decades was that we had this very stupid idea, quite frankly, of we have to get all of our electricity from 100% renewables. And so people were forcing wind, solar in places where it doesn't make sense. It doesn't make sense to go full on solar in the UK, not a very sunny place. Just like it doesn't make sense to go full on wind in a place that's not very windy. However, in California, it does make sense to have solar. The solar potential there is amazing. Same in Arizona, same in Texas. I think we have to move much more towards a locally grown kind of energy system where we are deploying technologies in places where they make sense. And what I love about nuclear is that it can go pretty much anywhere, including the desert, which is, I just mentioned we have that plant that operates beautifully in Arizona.
Okay, so let's go through some of the objections that you've heard a gazillion times. You mentioned the first one, the association with the atomic bombs. Chernobyl, Fukushima, 3 Mile Island, And then Jane Fonda's The China Syndrome movie, which came out just weeks after, or no, came out weeks before the 3 Mile Island, which was just
12
unbelievably
days.
12 days. Yes, unbelievable. You had one of your TikTok videos on that showing Jane Fonda. Yeah, I mean, well intentioned, but okay, what's the reality about these disasters?
I know that honestly, the whole timing of nuclear history has been quite amazing to
Yeah,
learn. You know, the
yeah.
connection with the bomb, obviously, but then to your point, the China Syndrome, which is this thriller about a journalist that's visiting a nuclear power plant and there is an accident and they cover up the accident. So it's a thriller about a nuclear disaster that comes out 12 days before 3 Mile Island in Pennsylvania. One of the reactors there has a partial meltdown. So obviously people were very freaked out. This was the nail on the coffin for the nuclear industry, I just want to say. So they bring up the accidents like 3 Mile Island was the first one. This was a very interesting accident because nothing happened. There was a partial meltdown, but the plant, even though it was a plant that was built in the 60s, it the safety systems kicked in and it was doing exactly what it was supposed to do. There was some human error where the operators overtook the safety systems because they didn't get correct readings on what was going on at the plant. And that's why the core partially melted down. However, the exposure to radiation for people around in the community was minimal. All the scientific studies since then tell us that nobody even got sick from it. They didn't expect an increase in cancer cases. Obviously, nobody died from it. So it wasn't really a scary accident, right? But I think because of the timing, it got seared in people's minds that it was way scarier than it was. And people had to be evacuated. So there is an emotional connection with that as well. But in terms of the facts, the science, nobody got sick, nobody died. Then you have Chernobyl in 86, which was a different story. Now we're talking Soviet Union, very secretive society, a really horrible reactor design. Didn't have a containment dome, which is a concrete and steel little house that you put on top of the reactor to prevent radiation from getting into the environment. A bunch of design flaws. And that caused a massive explosion and fire that spewed radiation into the atmosphere. And what made things worse was that, again, because it was the Soviet Union, they didn't tell anybody. So people were drinking contaminated milk and eating contaminated food for the days after that. So in that case, we did see people dying from radiation exposure, very, very high radiation exposure. We also saw people getting cancers, especially thyroid cancers. But again, the numbers are not as
Hmm.
crazy as people would think. The most credible estimates place the cancer deaths at around 4,000 total from Chernobyl, which, if you compare to fossil fuels, there are at least, I'm being very conservative here, at least 4 million people that die every single year in the world from the normal operation of fossil fuels. This is just fossil fuels operating normally without any accidents, right? So you'd need something like 200 Chernobyls happening every single year for nuclear to even begin to be as dangerous as fossil fuels. And then Fukushima was, obviously a gigantic earthquake, which is not what caused the accident. What caused it was the tsunami, which inundated the generators that were supposed to do the cooling of the reactors whenever electricity got shut down. So that didn't kick in. You had meltdowns. But again, the safety systems were much more evolved than Chernobyl. So for that reason, the radiation exposure to the public as well was very little. Again, not expecting any cancer deaths from it.
Can't you take trips into the Chernobyl area now? And apparently, it's a great wildlife refuge now.
Totally. That's the thing that's that's most surprising to people. Well, a couple of things are very surprising. One of them is there were 4 reactors at Chernobyl. One of them obviously exploded. Um, However, there was a reactor that was right next to it. It shared a wall. That reactor kept operating until the year 2000,
Yeah.
making electricity, no problem. People were going there, working. You think it's this like dead zone that nobody's there, no animals are there. Animals are thriving. There are no 3-headed animals or three-eyed, two-head. The animals are actually thriving because there's no human presence.
Right.
So it turned into this accidental experiment in rewilding, which is very interesting.
Yeah, it's a little bit like the demilitarized zone between North and South Korea, which apparently is a dewilding or a wilding place. Yeah.
Oh, really?
Oh yeah.
I've never read about it.
Oh yeah, yeah. It's supposed to be really well. You're not allowed to go in it really without permissions or whatever. You have to be careful not to get too close to the North Korean border.
Right.
I've been
Yeah.
pretty
That would.
close to there, but anyway. Okay, so yeah, so there's that, and then there's something else about nuclear that I want to talk about for a second that seems making it taboo in a way that other technologies don't. I'm going to read just a little portion from Steve Pinker's book, "The Better Angels of Our Nature," where he's talking about nuclear weapons and and why chemical weapon taboos took hold. Like, for example, they were used a little bit in World War II, but not in World War One, but not in World War II. Okay, so there's discussions about why that is. And so Steve writes, whatever suspension of the normal rules of decency allows warriors to do their thing, it seems to license only the sudden and directed application of force against an adversary who has the potential to do the same. The let's see, but the poisoner, like even pacifists may enjoy war movies or video games in which people get shot, stabbed, or blown up, but no one seems to get pleasure from watching a greenish cloud descend on a battlefield and slowly turn men into corpses. The poisoner has long been reviled as a uniquely foul and perfidious killer. Poison is the method of the sorcerer rather than the warrior. And so then he cites in Venomous Woman, the literary scholar Margaret Hallisey explains the archetype. Poison can never be used as an honorable weapon in a fair duel between worthy opponents as the sword or gun male weapons can. A man who uses such a secret weapon is beneath contempt. Publicly acknowledged rivalry is a kind of bonding in which each worthy opponent gives the other the opportunity to demonstrate prowess. The dueler is open, honest, and strong. The poisoner, fraudulent, scheming, and weak. A man with a gun or a sword is a threat, but he declares himself to be so, and his intended victim can arm himself as well. The poisoner uses superior secret knowledge to compensate for physical inferiority. A weak woman planning a poison is as deadly as a man with a gun, but because she plots in secret, the victim is more disarmed. Anyway, so Pinker then
Mm,
takes this and says, well, maybe we have a kind of an evolved repulsion about invisible poisons that you can't see or smell or taste. And nuclear has to be that in spades. I mean, it doesn't smell it, you can't see but it kills people through radiation, which you can't measure without a special technology and so on. So I do wonder if there's something else in our evolved psychology that makes people, even though they get all the numbers like you have in your book, and they go, no, but there's something, it's right there. There's the big concrete dome, and something bad is going to leak out, and I won't even know, and I'll be dead.
well, there's definitely that connection. To your point, it's something we can't see, we can't taste, we can't smell. It's just, and the thought that even something that we can't see, taste, or smell can kill us in seconds, right? If you're exposed to spent fuel in totally exposed, you will die. And so this idea is, it's, I would say it's even more than we have evolved, because I don't think we had time to evolve to even comprehend something like this. It just seems so out of the realm of what's possible
Mm.
and what makes sense in our human evolutionary history, that I think it does create this uncanny feeling in people. It almost feels like an alien technology that we can't fully understand. To this
Right?
day, right? I mentioned about we can access the energy inside of an atom. What does that even mean?
Yeah.
Right? Our brains have not evolved to comprehend that. We can't, we don't perceive the universe at that scale. So I think there is an uncanny valley aspect to it.
Mm.
There's an outside element to it, and there's also, again, the connection to the bombs, because you hear the word nuclear and most people's brains goes mushroom cloud.
Yeah.
It's just an automatic connection, again, because of that unfortunate timing in history. But it does seem to have this very different effect than everything else. Airplanes are a little bit like that as well. You can tell people that flying is very safe, that airplanes are one of the safest forms of transportation, and still they'll get on the flight and feel that anxiety.
Mm-hmm.
Because again, I think it also doesn't feel natural to be cruising the sky at hundreds of miles per hour
Mm.
inside of a metal tin.
Hmm. And also, you don't have any control over it. You're just sitting there. Whereas in your car, you feel like, well, I'm
Yes.
in control, so I can drive and text.
Right. And text and take selfies.
Yeah, it's crazy. Yeah. Okay. Then the other big objection is the nuclear waste, the half life of tens of thousands of years. Come on. You think you can safely store it for tens of thousands of years? Why not just shoot it to the sun? Well, we can't do that because then maybe the rocket will blow up over Florida or Vandenberg Air Force Base and we'll be stuck with it all over the place. All right, go ahead.
Yeah, everybody wants to shoot it into the sun, which is really funny. The risk with that obviously is that the rocket full of nuclear waste would go into space, blow up, and then all the nuclear waste would be on Earth, which is not ideal, not what we want. Some people have talked about putting them in
Mm,
volcanoes, which I think also, if you have an eruption, I think it's bringing that material out. So
mm,
not a good idea. Despite all the sci-fi options out there, the scientific consensus on what to do with nuclear waste is pretty clear. It's you just keep it away from the environment and people. That's all you need to do. So how do you do that? Right now, the way we do it is we take the fuel that was used in a nuclear reactor, which by the way is solid, it's not liquid, green goo, going anywhere. Thanks, Simpsons.
yeah,
Um,
right.
so you take that solid waste. It is very, very radioactive and very, very hot. So they put it inside of a pool, like an actual just water pool. And the really crazy thing is that water is so good at blocking radiation that even at this stage when the waste is the most radioactive, the most dangerous, I can visit a spent fuel pool, which is what they call it, without any protection. Just the water on top of the waste is protecting me. And so we did that for like 5 years until it cools down to manageable handling temperatures.
5 years. Wow.
5 years,
Okay.
yes.
All right.
And then we put it inside of this giant casks that are called dry casks, a very dry name for a very dry thing, quite honest, because it's very boring technology. But it's this huge, kind of like a Pringles can cask that's made of concrete and steel. Those are very, very good things at blocking radiation. So they put it inside of those casks, bolt it shut, and then put it in the nuclear power plant, in this case, in the United States. And I wish I could explain to you a visual, because I just visited the Diablo Canyon plant again in California,
Mm.
and we walked by the waste facility. And when you look at it, it's I don't know, maybe they have 40 of those. I don't know the exact number. It's not a huge place. And you think that that is the waste from generating electricity for 4 million Californians for 40 years. It's such a small amount. If I were to get my whole life's energy needs from nuclear, my waste would fit inside of a soda can. That's how small it is because, again, nuclear is so dense.
Mm-hmm.
And the other thing I like to talk about is, when people say, what about the waste? What about the waste? I have actually come around to understand that the way the nuclear industry, and I'm talking about the electricity industry, not the weapons industry, because those are separate, different wastes actually altogether. The way that the nuclear electricity industry takes care of nuclear waste should be the way we think about waste management for our entire society.
Mm.
I think it's appalling that we have a mountain of plastic trash in the ocean that's breaking down, harming marine life. I mean, forget about fossil fuel waste, right, which is spewing into the atmosphere. The way we handle waste in general is a mess. It's leaking into the environment. It's hurting people.
Apparently, I
And
shouldn't even be doing this.
I know, I'm totally anti-plastic. I don't want to get into like a plastic rant here, but I mean, the more studies, every year more and more studies come out of just the prevalence of microplastics everywhere in the world, in everyone, including newborn babies. And yes, I mean, I wish we took care of our plastic waste the same way we care for our nuclear waste, which is monitored, put inside of containers that are away from people. Um, but, people still want to know, but what about what happens in 100 years or whatever, which is great that we're thinking that far ahead, right? So I just came back from Finland, where they built the world's first deep geological repository for nuclear. And this is just a really, really deep tunnel. It's like 400 meters down below the surface. And the goal is to put the waste casks that we talked about there, and then they fill it up with clay and shut it down for eternity, basically. And they built this tunnel in a region that is extremely geologically stable. It hasn't moved in millions of years, and that's kind of the end of it.
Those are projected to then last tens of thousands or hundreds of thousands of years.
Well, there's nothing really you need to do other than just shut it with clay. The biggest concern really is that the radiation somehow would migrate to the surface. That's the only concern with these facilities. But again, they chose, first of all, they built very far away from water tables. And then they choose a region that's very, very geologically stable, so you don't have things moving around too much.
Mm.
And then they use materials that prevent, if there is any water. They do all this extremely advanced calculations to calculate if there was worst case scenario, right? There is some water that makes it to the surface.
Mm-hmm.
By the time the water got to the surface, it wouldn't be that radioactive anymore.
Do you know Stuart Brand, the Whole Earth catalog
Yes,
guy? Yeah,
yes.
yeah, yeah, yeah. So his Long Now Foundation thinks about these questions. Like
Mhm.
what would life be like 10,000 years from now, or 100,000 years from now? He's got that clock of the Long Now device, essentially a clock that like ticks every century or something in the last 10,000 years. We're not used to thinking along those long term time horizons, but yeah, you have to do that here. And also, I want to point out, that whatever the waste storage calculations are, compared to what? Well, if you're complaining about burning fossil fuels and the waste is just going into the atmosphere,
Right.
well, that's just pretty open and out there for all of us to be contaminated by it. And that is happening, or the plastics, as you mentioned, or whatever. So why complain so much about these high-tech storage devices that will probably work, and then put your high-risk concerns over that, whereas there you are just spewing stuff into the atmosphere or the oceans.
Yeah, and another thing that I want to point out is that the scientists are not just pulling these ideas out of thin air, right?
Right.
Well, like, they're not just like, I think it's going to work, but we don't know. They're doing very serious calculations. We're very good at tracking radiation. For example, when Chernobyl happened, the Soviet Union didn't tell the rest of the world.
Yeah.
And the way the world found out was this nuclear power plant in Sweden detected elevated radiation around it. And the operators were like, okay, let's check our power plants. They checked their reactors. It was totally fine. So they analyzed the specific isotopes they were detecting. Okay, they could already see what specific isotopes they were detecting and analyze the wind patterns. And they traced it back to Chernobyl. So we can detect radiation extremely easily. It's something we've known how to do for a long time. But also, and this is the craziest thing of all, there were natural nuclear reactors on Earth 2 billion years ago. I know it sounds insane. I'm not making this up.
What is that? The Onkalo Deep Geological Repository? Yeah.
No, that's the one in Finland that we're building,
Okay.
but Oklo,
Oh, Oklo, that's it. Yeah.
yes, in Gabon in Africa, there was this what we now call a uranium mine, but there was this area with a very rich deposit of uranium, and because of very specific geological conditions, there was nuclear fission happening inside of those caves, which is fascinating. And those fission events, they created fission products and things that we call waste, the same thing that we create in nuclear reactors. And we can trace those. We know exactly what happened to them. And the truth is, they didn't move that far, even without any technological barriers to prevent that radiation from moving. It just didn't. And so again, we have we have the past to look into, and we're very, very good at analyzing and calculating radiation.
I know you support the Nuclear Regulatory Commission, the NRC, as a necessary element here in the equation, just to keep things safe. But one libertarian argument you often hear is that the nuclear industry is overregulated, and that's why we're still using 1970s technology. Whereas
Mm.
other industries, the airline industry or the automobile industry or whatever, was allowed to have failures and learn from them and grow and develop new technologies to solve old problems. What do you make of that argument?
I hear that argument very often right now. It's very on trend to, say things like abolish the NRC, the Nuclear Regulatory Commission. And people will use this fact, which is totally wrong, by the way, that since the NRC was formed in 74, they haven't licensed a single reactor. That's not true. They
Hmm.
have licensed 14 reactors.
Hmm.
They didn't get built, but it wasn't because of the NRC.
Hmm.
They didn't get built because nuclear, somewhere along the way, it was a mixture of overregulations, especially after 3 Mile Island, because lots of regulations to make all the plants safer kicked in. So that made the technology more expensive back then. The public perception, but it was also interest rates at the time and supply chains at the time. For a combination of various reasons, nuclear became very expensive, and utilities just didn't want to build them. So to blame it all on the NRC is wrong. It's infactual, right? You're not basing your argument on something that is factual. But I think it's also dangerous. So I'll give you an example. I recently went to an NRC meeting in Pennsylvania about the restart of the 3 Mile Island plant because it's now being reopened, which is just very poetic. And I was just listening in because this was the community, and I didn't want to say anything. It's not where I live. And out of all the people, people of all different backgrounds stood up, and some of them were pro-nuclear, some were anti-nuclear, but almost all of them brought up the same thing, which was, we are seeing changes at the NRC. We're seeing that people are being fired from the NRC. Do you have enough personnel? What is your budget? We want to make sure that our community is safe. And so I think from a public perspective, to abolish the NRC is the most tragic thing you can possibly do. And I say this as somebody who has been advocating for this technology for the past 5 years. Make it more efficient? Of course. We all, we would all love the NRC to be more efficient. But then also, if you abolish the NRC because your whole reasoning is that this is the reason why nuclear has failed, you're not solving the actual problem, which is, how do we finance this plant? How do we have better project management so that we don't have delays, which leads to cost overruns and so on? So I think it's a fake problem, and abolishing the NRC is a fake solution that's only going to hurt the industry as a whole because people are going to go back to fearing it.
Okay, what does it cost to build a new nuclear power plant, let's say the equivalent of a Diablo? Or should we not even be doing that? Because you also talk about microreactors and small modular reactors and so on. Where should private industry put money in? And one last question on that. Is it so expensive that we need a government private industry sort of tie-in?
When you look at countries throughout the world that have been successful at deploying nuclear at scale, it was always some sort of combination of government and private industry because they are expensive. Even if they are cheaper than what they cost right now in the United States, it's still a huge upfront cost. The majority of the cost of nuclear in general is building the facility. The operating cost is actually quite small, and the fuel cost is tiny. But building it is very, very expensive. And, it's a project that takes 5 years or so. And so you basically need to be able to borrow money at very low interest rates, which is where the government comes in, which, China does extremely well.
Yeah.
The same was true for France. The same is true for China right now. That was one of the reasons why the U.S. Didn't take advantage of the nuclear era that they had in the 60s, where they were building a lot of reactors, but then each utility was building different reactor design, and so there was no aggregate learning. And that's obviously the thing that brings costs down, right? Is you do something over and over and over again, you get better at doing it, you get faster at doing it. That's how you reduce time and cost. In the United States, we were never fully able to do that, partly because of this lack of centralization, right? Which is a lot of libertarians don't like to hear that word. How much does it cost? Very spicy topic. I hate to talk about this because it is very expensive in the United States. To put into context, though, for 30 years, the United States didn't build a single nuclear reactor. Okay, so 30 years where the industry was pretty much dead in terms of building new stuff. Then we started building 2 reactors in Georgia at the Vogtle Nuclear Power Station. Reactors 3 and 4, they already had 2 reactors there. And these reactors were supposed to cost $15 billion both. They ended up costing 35.
Mm.
So
2x.
extremely expensive. Exactly. Extremely, extremely expensive. Now, what do? Well, yes, it was very expensive, but we got that entire workforce that now knows how to build these things. So actually, the biggest waste would be to waste all of that learning and not build the same reactor again. That's why there is a push to build more of those same reactors, even though nobody in their right mind wants to do it. But that might be the best next step here. China is building reactors of that same size, which are the big reactors, in about 4 or 5 years, and they cost about $3 billion each, which is very, very different than what ended up costing the United States. So China is building nuclear at a cost that's comparable to methane gas, which is incredible, and very fast as well. But there's a whole new generation of people who believe that we don't have to build these large reactors because we have small modular reactors and we have microreactors and so on. And this is something that is very exciting. The whole idea behind this technology is nuclear is too expensive. No private company is ever going to take on the risk of building this. So how do we make it cheaper? Well, we make it smaller because obviously a smaller plant is going to cost less, right? However, here's the problem, and I try to warn people a little bit about this, is we, in the 50s, when the US government was going all crazy on nuclear, they built a bunch of different small reactors. Very exotic fuels, very exotic coolants. They built a microreactor for the army that was portable even. But what happened was they were always more technically complicated than anticipated, which meant they were not very reliable and they were very, very expensive. So they were never able to compete with fossil fuels on cost. You know what could compete with fossil fuels on cost? Making the reactors bigger. So slowly they started making them bigger and bigger and bigger. And that's how we ended up with the big reactors that we have today.
Interesting.
Now, can it be that we had a miracle in material science advances and we can now have less neutron leakage from microreactors, which is one of the problems that microreactors have? Sure, but we don't know. And I don't want us to put all of our eggs on this radioactive basket.
You have this picture of the Ford, a nuclear-powered Ford car.
Yes, horrible idea. Don't do it.
But, cars aside, there are nuclear submarines and nuclear-powered aircraft carriers.
Totally.
And so why couldn't every city have the equivalent of that, or neighborhood or whatever?
So for submarines and for aircraft carriers, they can pay a little bit extra for that price. But when we're talking about electricity that's sold to consumers, you're talking about something that has to be competitive with fossil fuels, right? Now, data centers are an interesting example here because data centers do have the capacity to pay a little bit more for electricity. And we are already seeing that with the data centers that are making power purchase agreements with some nuclear companies. They are paying way over what, you would buy electricity normally from the grid from. So there is a potential here. But again, we haven't even built a prototype of any of these reactors. We don't know if any of them are going to pan out. I hope they do. But we have no idea at this moment. And I don't want to waste all of this excitement, that we have public acceptance. We have bipartisan political support. We have private investment coming in. And I don't want us to waste it on technology that we don't know if it's going to work.
Nice. Yes, well, maybe after Elon gets finished colonizing Mars, he'll turn to nuclear power plants.
Well, but as you know, nuclear is very interesting for space in general.
Yeah.
Nuclear batteries for space exploration, like Voyagers 1 and 2, were powered by nuclear batteries, which they're still out there. They were launched in the 70s, and they're still out there sending information back to Earth, exploring the outers. They're in interstellar space right now, which is just so cool. Same with
Cassini, you mentioned
Cassini as
Carolyn's
well.
project, yeah.
Exactly.
But weren't there protests about the launching of the spacecraft
There
itself?
were protests, and me and Carolyn, we talk about this a lot because she was doing a lot of the public communication for the Cassini mission, which, just for those who don't know, was a Saturn mission. And yes, it was powered by a nuclear battery, and there were protests, people saying that if there was an atmospheric reentry during a flyby on Earth, um, that fuel could kill people all over the world, which was just complete made up nonsense.
Yeah.
So she was out there already doing the work of trying to educate people on the dangers of radiation and this technology. But then even when you talk about planetary exploration or the moon, there is an argument to be made that nuclear is the best energy source because in Mars, for example, which we don't know if we're gonna get there, but one of the issues in Mars is that you have a lot of dust storms. So there was a Mars rover. I can't remember exactly what it was, if it was Curiosity or one of them, was powered by solar. And this is so embarrassing. They sent this rover to Mars, powered by solar. There was a dust storm. The solar panels got covered, and it died.
Unbelievable. Yes,
Unbelievable. Like, you
I
didn't
remember
think
that.
about this. And so, if you're going to have massive solar arrays that are covered in dust constantly, how are you going to clean that up? How are you going to send so many solar panels to Mars in the first place? So nuclear makes a lot of sense for space exploration.
Yeah.
So maybe Elon should get on it.
So, the people who oppose nuclear energy, what percentage or how would you divide it up between those who know all the facts that are in your book and they object to it anyway because of some other reason, or are they just ignorant of this? And if they knew the facts, they'd go, oh, yeah, all right, you're right. I changed my mind.
As you know, Michael, us humans, all of us, we make decisions based on emotion. And then we use science and facts to justify our decision. But we make decisions based on emotion. And I've seen this progression. I've seen even in some environmental organizations. They will oppose nuclear first because of the waste, then because of Chernobyl, because it's too risky. And then the data comes out, but now they oppose it because it's too expensive or it takes too long. So they are still opposing it. They just keep changing the argument. So they keep using
Moving the
others.
goalpost.
Just moving the goalposts.
Yeah.
That's what happens. One of them, the NRDC, which was behind the closure of Indian Point in New York,
Right.
which was a tragedy. Indian Point shut down in 2021, and all of its electricity output, all of it, was replaced with fossil fuels. Just a tragedy. And NRDC was so anti-nuclear, so it never called nuclear clean energy. And then when the data center companies started making announcements on restarting nuclear plants or investing in nuclear technologies, then they started saying, well, we don't want this because the data centers are going to get clean energy and not going to give it to the rest of the population. So they just keep changing the argument, but it's always something against. They always want to be against nuclear. So, but that's, I think, a generational thing.
And I guess that's getting back to that psychology of what's natural, organic, like no GMO foods. They're all GMO. I mean, we've been genetically modifying foods for 10,000 years. No, I don't mean that. I mean this other. There's something about that psychologically speaking. You have a whole chapter on the degrowth movement, which I've also followed. Annoyingly loud, you call them. Yes, I agree. But it's even worse than that. I mean, there's the anti-natalist people. People shouldn't even have babies.
I know.
Of which Elon is apparently fighting personally against. And yeah, so what is it about that? It's that so nuclear gets wrapped up in that whole degrowth. We should go back to the way things used to be in the good old days. So talk about that a little bit because you have that example in that chapter about what it was like in the 1800s to wash your clothes and make ice cream.
I mean, forget about, yes. There's this very cool, for those people who love a really obscure YouTube content. There's this really cool account called I'm skipping on the name, but First American. I'm gonna have to look it up. You're gonna have to put it on the notes because I forgot. It's like First American or
Early American.
Early American.
Yeah.
There's this really cool YouTube account called Early American where it's a couple, but they only have technology from the late 1800s and early 1900s.
Yeah.
And they only make recipes from then too, which is, I love it. They also make it very ASMR for those who like ASMR. So she's kind of just whispering and moving things around. But
Oh.
in one of the recipes, she makes ice cream, which at the time, ice was really hard to come by.
Hmm.
So she has to get this huge sheet of ice that she breaks down with a hammer. And then she puts all the ingredients, the cream and the flavors and so on, in a container. And then she churns the cream for 2 hours with her hand just to have a little bit of ice cream, not even that much. And by the way, you have to eat it all because you don't have a freezer, to keep it in. Um, Obviously, that's kind of a funny story because people are like, I can't believe you're talking about ice cream making. It's just a funny, way to explain how hard life was.
Mhm.
But yes, I mean, even for people that live today, there's like 600 million people in the world that don't have access to electricity
Mhm.
today. And so, how are these people's lives? How do they cook their food? They don't have, obviously, air conditioning, dishwashers, laundry machines, and so on. And so, life gets a lot easier when you get access to electricity. Now, I do think, listen, I am a mom, and I am somebody who's actually very concerned about toxins in the environment. And we're very lucky to be born post EPA. But in the 60s, there was a river, the Cuyahoga River, that caught on fire like 12 times because industry was just dumping their chemical waste into it. So I definitely empathize with the argument that we can't just be evolving technology and dumping everything into the environment. I'm totally on board with that. But this idea that the only way to solve the climate crisis is to somehow drastically reduce our energy consumption, to me, is just so out of touch with reality, with how the world works. And again, it's so privileged. And I never heard one person from a developing country tell me that. Never. It's
Right.
always somebody from America or an European nation. It's never somebody from Ghana who like desperately wants a laundry machine so they have more time to play with
Yes.
their kids or learn a new skill.
That's what,
Um,
yeah, Rob Henderson calls those luxury beliefs. These
right.
these are people sitting in Starbucks on their laptops, complaining about third world countries wanting to use fossil fuels so they can have energy too.
Right, which is, I mean, that is straight up just evil, right? I mean,
Yeah.
you have to be an evil person to actually believe that. I think, to be fair to a lot of these people, I don't think they mean that. I think they mean wealthy countries,
Mm.
should drastically reduce their energy consumption, which I think is a beautiful idea, but is just not practical. And furthermore, especially in a place like America, how do you go about that? And that's the question that I always ask, and they never give me an answer, right? Let's just take the sentence. We should use less energy. Who's we? Is it
Yes.
you and your family? Is it your neighborhood? Is it your city? Is it your state? Is it your country? Is it your continent? Is it the world? And then what is less? Is it 10% less, 20% less, 50% less? And the most important question is, how do you enforce it, right?
Hmm.
Because if you're saying, okay, everybody in this country can only use this much energy, you're going to have to give out energy quotas.
Hmm.
And then what happens if people use more? Do they go to jail? Do you kill them? I mean, how do you enforce something like that, right?
Yeah.
So I think I understand where the idea comes from and the intent. But at the end of the day, because we live in societies that already have a very established energy infrastructure, the only logical outcome is that we prevent poor societies from developing because those are the easiest one to prevent increasing their energy consumption.
Yeah. Yeah. Well, I had Paul Ehrlich on the show, and he admitted he was wrong about the population bomb.
Oh, he did?
Yeah. 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 That he
When?
Well, he was on about a year ago.
Okay.
He has a new book out basically saying, yeah, we got the numbers wrong there. I mean, they were predicting, the end of basically hundreds of millions or billions of people would die by the 1980s and so on from starvation. Basically, they're just ignoring David Deutsch's principle of just find new solutions to problems and keep moving forward. And each new
Right.
solution to a problem will itself create new problems, but then you create new solutions to those problems and keep moving forward. The opposite of that is what you're encountering here is, well, let's go back to pre everything, pre industrial age. Let's go back to hunter gatherer days or whatever. It's like, you would not want to live in those days. It's like, if nothing else, the dentistry.
Mm.
you know,
Well, yeah, that for sure. Oh, there is an argument to be made that there are elements of hunter gathering that we might want to bring back, like more connection to
yes,
Earth,
yes,
right?
social, yes, yes,
Feeling like we truly like eating from trees that are around
yes,
us, a
yes.
better connection to the environment. So I think I don't want to just discard that as like, oh, nobody wants to live that way. I think it would be nice to bring some of the things back. However, again, it's about the pragmatism of how do you do that? Just look at the society that we have. How do we go back to how do we create that connection with the land again? How do we create better technologies that do reduce the impact on the environment?
Mhm.
And I think that's where nuclear is very interesting to me because it's doing exactly that. I think ideally we get to a point where pretty much every technology we create, we are thinking about the waste, what's going to happen to that waste 1,000 years from now, and we are thinking about how do we reduce. In nuclear, they have this principle called ALARA, which is as low as reasonably achievable. And it's this idea that they just keep lowering the amount of radiation that they expose the workers or that goes into the environment and the water, which is a tiny amount already. It's like not even significant. But they just constantly try to reduce that amount of radiation. I think that's a principle that also should be applied to other things. How do other industries keep reducing the amount of toxins they're putting into the environment? If you look at tap water nowadays, I mean, it's just basically somebody's trying to kill you. You have birth control and antidepressants and microplastics and all of these things in the water. So ideally, we can move more towards a place where we create better technologies that do solve those problems. But to your point, you're just eternally solving problems.
Yes. Yes, well, but the peak population is probably going to hit around 2050 at around 10 billion. And then we'll be
Okay.
back down around 8 billion by the end of the century. And it according to this book, Beyond the Peak, it's going to keep plummeting. I mean, there's not much anybody could do because once you get a country that's wealthy, and particularly if the women are economically empowered and educated, they just have fewer babies. It's just we're already below replacement level 2.1 in the United States. I think it's 1.6. Korea is like 1.1, South Korea, and probably half the countries or more of the developed countries are already below replacement level. So
Right.
in terms of the kind of energies we're going to need in the future, yeah, nuclear is the way to go. But the pressure on the environments may go down anyway, inevitably in the centuries to come. I recommend this book. It's really quite an eye opener. I mean, Elon was kind of calling uh, ringing the alarm on that a few years ago, but he turns out he's right. It's the deep. We're going to be depopulating
Hmm.
soon, so
Yeah,
that's
which
interesting.
is an interesting, even philosophical question, right? What does that mean? Is that a good thing? Is that a bad thing? We were told for so many years that it was a
Yes,
good thing
right.
because we need less humans. We need to put less of a burden on the environment. But then we just leave the world for AI. What's
That's right.
what's coming here? What's the future of planet Earth? I mean, I would ideally. I love humans, not just because I am one, but
You're biased.
I'm biased, but I love human beings. I would love to keep the world for us. And just creating better technologies that make human lives better and that also just makes the environment better, healthier, cleaner.
Yeah, yeah. Of course, we all want that for sure. And so it really just becomes what's the problem you're trying to solve and what's the best solutions, irrespective of politics or emotions. Of course, as you mentioned, that's the difficult part. Okay, let's say the Trump administration, someone in there reads your book and goes, "Hey," and Trump says, "Bring this Isabel into my office. I want to find out what the next big beautiful bill is going to do to fund nuclear power. What would you tell them? What's their pathway in the next, I don't know, a quarter century or so of what we should be doing?
I would pitch a wild idea. I would say that we should build 1,000 nuclear reactors in the next 20 years, which is very
Wow.
bold and ambitious.
Wow.
But that would be my plan. That way, we would if we fully electrified everything, we would have 100% clean electricity from nuclear. Now, how do we achieve that? There will have to be a lot of government support. One of the most important things, as I mentioned, is this ability to tap into capital with very low interest rates. So that is something that the LPO or Loan Program Office in the Department of Energy already does. Would be better if it did it at a larger scale. The other thing is keeping subsidies and tax credits for nuclear, which I know that libertarians don't like very much.
Mm.
However, we were in the depths of hell for 30 years with this technology where nothing was being built. We need to be able to bring it back to at least a place where it can be mature enough to not need it. We don't know how long that's going to last. But what's really surprising, Michael, is obviously the Trump administration is not trying to build 1,000 reactors yet. But they were very supportive of nuclear. So in this one big, beautiful bill that was passed, all of the incentives for nuclear from the IRA were maintained. There were a couple of changes here and
Nice.
there, but they were pretty much maintained. So that's what's so interesting about nuclear is it is such a controversial energy source. It has all this charged history, yet somehow it has bipartisan political support. So I really,
Mm.
really hope that it continues to be the case. I have worked with the Biden administration on it. I will work with the Trump administration on it, and I will work with the next administration as well, because I truly believe that not only nuclear enabling this technology, but also having the United States be the world's leader in nuclear is extremely important.
Nice. Perfect. Well, you're doing it. You're killing it. I know you've got some interview coming up here in a moment. You're on your online book tour, so
Yeah.
go. You go. It's great. You mentioned there's a throwaway line in your book about the fashion industry it being sketchy. Are you still in the industry? What's sketchy about it? Are you still doing it, or are you transitioning out of that entirely?
Mildly sketchy. At this point I have transitioned away from it. I still, I do a lot of photo shoots because so much of my advocacy is visual. I
Yeah.
still do photo shoots and work with fashion photographers and makeup artists and so on. So I still feel like I'm somehow a part of it, but I'm not working as a fashion model. And it is
Yeah, I don't think
extremely
I've ever seen an
sketchy.
author photo quite like that on a book. It's great.
What about the blurbs? Did you see the Paris Hilton blurb?
I did, yes. Yeah, let me find that here for you. Let's see. Of course, you have Carolyn Porco at the top, which
I
is
have
great.
Carolyn Porco at the
Yes,
top.
tech that helps the planet. That's hot. Rad Future is smart, bold, and genuinely hopeful. Bemke makes the case for nuclear electricity in a way that's fresh and inspiring. This book makes you feel excited about the future. Paris Hilton and Grimes, your buddies with Grimes. Yeah, that's so cool.
Yeah. Well, I'm just trying to do something different, bring people who historically don't talk about topics
Yes,
like this
yes.
into the conversation and getting people excited. So that's I honestly have to say this is because I was in the fashion industry for so long. I have this broader vision.
Hey, whatever it takes to get good ideas out there. I mean, your TikTok videos are very effective. Like every one of them, you have some different outfit on or sunglasses, or I don't know where you get all this stuff. do do companies give you clothes and things like that?
Some of them now, yeah, some
Nice,
of them now,
nice.
for
Yeah,
sure.
we want to be featured in your next nuclear TikTok video.
Yes, exactly.
That's great. All right, Isabella, thank you so much. Here it is again, Rad Future. Check it out. I think it's on audio too. I didn't. I just read
Yes,
it
I
straight
did the
through.
reading. I
You
read
did?
it. So,
Oh, I
yes.
love that.
I hope you like a Brazilian accent.
Well, I do like a. Who doesn't like a Brazilian accent? Come on.
You never know.
That's right.
It's me reading. Thank
All
you so
right.
much for having me.
Oh, you're welcome. Thanks for coming on, Isabella.